Good morning, class. First of all, I'm very sorry that I was not preparing any video for a fourth semester student. And as now I have completed my syllabus of inorganic chemistry in first year, so now I am available for you. And from this video, we are going to start our physical chemistry syllabus. So today is the third unit, as we had already discussed the first and second unit in the classroom. So today we are going to start the third unit, that is the electrochemistry. Third, I suppose. Third. So in this particular lecture, we will discuss the some introductory section of electrochemistry. So first is the difference between the electrochemical cell, and electrolytic cell. Electrolytic cell. So the difference, first, what is electrochemical cell? So the device which convert chemical energy to electrical energy. Very simple. Any device which convert chemical energy to electrical energy, that is electrochemical cell. Then the electrolytic cell, just opposite of this. This device convert electrical energy to chemical energy. Okay, so the device which convert electrical energy into chemical energy, that is the electrolytic cell. The second one, here we required salt bridge. The setup is like that. We required salt bridge. So salt bridge required. In this case, there is no need of salt bridge. No salt bridge required. Third and the important one, you must remember this, that here the spontaneous redox reaction occurs. Here the spontaneous redox reaction occurs. Here non-spontaneous. Then the setup has a different flow of electrons. So I'm writing this electron. In this case, electron moves from anode to cathode. Here electron moves from anode to cathode, but in this case what will happen, in electrolytic cell the electron is supplied by external battery. Electron, that means the electricity is supplied, as we know that electrical energy is converted into chemical energy. Okay, so electron is supplied by external battery and entered through cathode. So here we can say the electron is moving from cathode to anode. Correct. Now there are some things, some things which you need to remember, so I'm giving you a simple way to remember that things. Here in case of electrochemical cell, you need to remember the alphabets, okay, the order of alphabets. Like anode, for A, anode come first, A come first, then C, cathode, C come after A. So anode, then cathode. Similarly, oxidation, that means O come first, then R, reduction. Then the third is negative, N come first, N is come first, okay. So N, then P, MnO, P is the, for the positive. Then one more thing is there, the left, L come first, L, and the R, right. So this is how we can remember the electrochemical cell arrangement, that at the left hand, anode is there where oxidation occurs with negative charge, oxidation at anode, which is available in left side. At right hand side, positive charge, reduction occur at cathode. So this you can remember by the alphabet. Now similarly, in case of electrolytic cell, don't panic, we can remember it also. So here, don't panic, PANIC. So here the positive is anode, negative is cathode. What? Positive anode, P for positive, A for anode, negative cathode, okay. So at positive end, what will happen? Here oxidation occur, and at anode here reduction occur. So this is another simple way to remember the electrolytic cell arrangement. This we need when we give the schematic representation of cell reaction. This we required. So the panic here, and here the alphabets, the order of alphabets. Next, the type of electrochemical cell. So types of electrochemical cell. First, it is divided in two types: electrolytic cell, and the second one is the voltaic, where the voltage produced, or galvanic cell, okay. Then the voltaic cell divided into two type again. The first is chemical cell, and the second one is the concentration cell. Then the concentration cell is divided into type: electrolytic concentration cell, electrolytic concentration cell, and the second one is the electrode concentration cell. Then the electrolytic cell again divided into two type. This is called without transference. Without transference. And the second one is with transference. So this is how we can go through in this particular unit. These are the cells which we have to discuss during the course. The types of electrochemical cells: electrolytic, then voltaic cell is there. Voltaic cell is again two type: chemical cell and concentration cell. Concentration cell, then two types: electrolytic concentration and electrode concentration. Then the electrolytic concentrated cell with again two type: without transference and with transference. So as it is an introductory lecture, so let's discuss some of the electrochemical cell. As for your syllabus, we have to give some introductory lecture, complete some introductory part. So we'll just discuss some of the electrochemical cell. So types of electrochemical cell or electrochemical cell. So this I'm moving. Electrochemical cell. Here we are talking about the zinc copper cell. Okay, here we are talking about the zinc copper cell. So first let's see the setup, how the setup will look like. So here let's draw the two setup. This is the electrode, this is the another electrode, then the solution, then another solution in this setup, so this is the solution of zinc sulfate, zinc sulfate, and this is the solution of copper sulfate, copper sulfate solution. This is the zinc sulfate solution, and this is a connection between these two cells. Okay, here is the this is salt bridge, which is capable to separate these two solutions. Okay, with the help of the salt bridge we can easily separate these two solutions to intermix. So this is salt bridge. Salt bridge is the requirement in electrochemical cell. Now the very important, the electrode. This is zinc sulfate solution. So here the rod is of zinc. So this is zinc rod. It is copper sulfate solution. So this is copper rod. This is the negative charge. This one is the positive charge. So electron movement is occur from this side. Electron this electron, then this is like, so this is how the electrochemical cell looked like, zinc copper cell. Now as we had discussed in electrochemical cell, the anode is the part where oxidation occurs. So you can see here that anode where oxidation occur and cathode where the reduction occurs. That means the negative charge which is in left side where the oxidation occur. Okay, so let's start the half cell reaction. So here at anode, this is the anode, what happened, the zinc, that means I'm talking about the zinc sulfate. Okay, this will oxidize, anode oxidation occurs, so the zinc is oxidized, zinc plus 2, and it will release 2 electron. So this 2 electron will move from this. Okay, this is how the electron movement occur. And then at this end where the copper rod is there, what will happen, then these 2 electron is taken by copper. So copper plus 2 is already there in the solution, and this 2 electron will reduce copper. So this is oxidation half cell and this is reduction half cell. This is oxidation half cell and this is the oxidation half cell and this is the reduction half cell. So finally we can write the complete cell reaction. The complete cell reaction where the left hand side is oxidation part and right hand side is the reduction part. The left hand side is the oxidation and right hand side is the reduction. So this is the left side and this is the right side, and we know that at left side what happened, oxidation. So we will write like this, zinc, this is solid, so zinc plus 2, this is C1, this is the aqueous, and this one is the salt bridge. At right side reduction occurs, so reduction of copper plus 2, this is again C2 at copper solid. And this is how the cell schematic representation of a electrochemical cell, where left hand side oxidation occur, this zinc solid, this is the rod, and this is the aqueous solution. C1 represent the concentration, it can be any concentration. Sometime you find here aq represent what, aqueous, similarly aq. And here the C2 concentration of copper, it can be any concentration than copper. So this is how you can write the cell reaction with the anode half cell and the cathode half cell. Then we will talk about one more cell, that is the electrolytic cell. Electrolytic cell. So the electrolytic cell, here we required only one setup because there is no need of salt bridge. Okay, so we will go for only one single setup, although two electrodes is there, but in one setup only. So the two electrode, will find the first electrode, this one, then the second electrode, then the solution. Here this is a positive charge and this one is the negative charge. The battery from where the supply is given. So this negative is cathode. Okay, and positive is anode. As it is written here, you can see that negative is cathode and positive is anode. So at anode oxidation occur, and at cathode it reduction is occur. Got it? And this is the two electrode. These two electrodes are actually inert electrode. This is called inert electrode. Okay, and here any solution we can take, aqueous solution of any electrolyte, aqueous solution of electrolyte we can take, like for this case NaCl we can take, molten NaCl, and these two are the inert electrode. So what will happen, as it is a positive charge, so what will happen, the negative charge is attract towards it. Okay, the negative charge is attracts towards it. So here the negative charge they will attract, that means what, the Cl negative, and the solution Cl negative is there, so Cl negative goes to this side, and similarly the positive charge will attract toward this cell, so Na plus this will go to this side, the positive charge will go to this side. Okay, so this is how the setup will look like. Then the cell reaction again at anode. Here at anode what will happen, at anode oxidation takes place. So at anode oxidation, so oxidation of what, oxidation, that means the chloride ion Cl negative is will give one electron. Okay, here -1, here 0, so this is what the oxidation. Now this negative electron I'm talking about, as the supply, when we give supply from the outside, this sodium chloride, the solution of the sodium chloride get melted, and the electron, the negative charge electron will travels to this positive charge. Okay, so this as it is an inert electrode, so this negative charge will travel towards this positive charge, and then the cell reaction will complete. Okay, so this at anode oxidation occurs. And at cathode, what happened at cathode, so at cathode reduction takes place. So reduction of what, Na plus is there, and this Na plus by getting one electron, that means plus E converted into Na. So this is how the reduction and oxidation takes place. Some numerical values also we can remember, because to oxidize this oxidation chloride ion into chlorine, this oxidation required 1.36 volt of supply, minus 1.36 volt, whereas this reduction required minus 271 volt of supply. Okay, so the overall the cell is 4.07 volt. This is what the setup of NaCl. So this is the two types of cell we had discussed. There are so many other, like in electrochemical cell you can go for the copper and silver type of cell, and this is the this schematic diagram of these two cells. Now let's discuss some of the few definition, and then we will complete this discussion. So the first is electrode potential. What do we mean by electrode potential? Electrode potential. So electrode potential, this is the tendency of an electrode to gain or lose electron. This is electrode. Okay, then this is an electrode. So what is the tendency of this electrode to gain or lose electron? when it is come into the contact of its own ion in the solution. So what is the definition? Tendency to lose or gain electron when it comes contact with its own ion in solution. Okay, so electrode potential, I'm talking about the potential of this electrode, whatever tendency of its electrode to gain or lose electron. Then the standard, what is the standard electrode potential? So standard electrode potential is nothing but the electrode potential at standard condition. Standard electrode potential, that means the electrode potential at its standard condition. So what is that? Temperature is 298 Kelvin, pressure is 1 atmospheric pressure. So this is the standard condition. At this condition, whatever is the electrode potential, that is called the standard electrode potential. And the last definition, that is very important, like we have written this is the EMF of the cell. Okay, so the EMF, what is the EMF? Electromotive force, the force which causes the flow of electron from one electrode to other electrode. The force which causes flow of electron from one electrode to other. Okay, which is called electromotive force or EMF. So these are some few definitions which you have to remember, and this is all about for the first lecture. Thank you so much.